today's lesson, we are in Unit 3, Polynomial Equations and Inequalities. Today's lesson focuses on dividing polynomials. So yesterday, in our first lesson, we focused on factoring polynomials, okay? And today what we're going to do is we're going to focus on dividing polynomials. Now I'm just going to start by kind of going over, making a kind of a connection between factoring and dividing, and then we'll get into long division here and how that's going to help us. I'm just going to slide over for a second here, and we're going to say we are going to look to fully factor or prime factorize the number 24, okay? So basically what I'm doing when I'm finding a prime factorization is I'm finding all the prime numbers that are factors of 24, and so we'll see how this works here. So we're going to go 24. What are two numbers that go into 24? They are maybe 12 and 2. Okay. 2 is a prime number, so I'm just going to circle that. We can't factor 2 any further other than 2 and 1. Now we're going to build off 12. So 12, I can factor that into 6 and 2. We have another prime factor here. And if I continue this one step further, factoring 6, or what two numbers multiply to get 6, we get 3 and 2. And so what I've done here is I've basically gotten all the smallest factors of 24. And so basically what I can do is I can write out and say that 24 is equal to 3 times 2 times 2 times 2. Okay, those are all the factors of 24. Multiplied together, they equal 24. I can also write that as 3 times 2 cubed. Okay, again, these are factors. So what we've done with 24 is we've kind of factored 24. Okay, so this kind of idea of factoring, we're going to do this again today. Now notice that one way what we're doing when we're factoring here is I'm taking 24 and I'm dividing it. Oh, I apologize there. I'm dividing it by 12. And that's how I get another 2, right? So there's this kind of connection between dividing numbers and that when we divide, that helps us find factors, okay? So we're going to use that idea that division gets us to factors, okay, in today's lesson. All right. So one thing that we need to kind of talk about before we get into this is how we use long division. Because today's lesson, there's two strategies we're going to use to divide polynomials. The first is going to be using long division. The second is going to be using a kind of a shorter process called synthetic division. So what we do for dividing long division is we're going to take two numbers. We're going to go 249, and we are going to divide that by 15. To see what we get, okay? Now with long division, it's maybe been a long time since you've done this. Maybe you've never done this. What we're going to do is this is the setup. We write the number 15. Oh, let me just make a little bit more space here. We're going to write the number 15 here, and then we're going to write a nice little kind of, this is like our division symbol, and underneath there, we're going to put 249. Okay, now these numbers, each of these numbers have definitions, or what they're called, okay? So for example, 115, this is known as our divisor. This is what we're dividing by. So we can see the divisor down here, okay? We also have 249. This is our dividend. And then we're going to have the number that we're going to put up here, which is going to be our quotient. Okay, and so you see all those names down here, and then eventually at the bottom we're going to determine what our remainder is. So in order for me to divide 15 by 249, what I'm going to do is I'm going to start with my hundreds column, okay? And I'm going to say how many times does 15 go into 2? Does 15 go into 2? No, it does not. 15 is too big. It does not go into 2. So if it doesn't go into that first number there, what we're going to do is we're going to kind of expand our search. We're going to say, okay, does 15 go into 24? Well, yes, 15 does go into 24, and it goes into 24 one time. So I'm going to put my 1 above at the top there, above the 4, okay, in my tens column. Now what I do once I put my number up there is I'm going to take that number, the 1 that I just got, and I'm going to multiply it by 15, okay? Oh my gosh, I apologize. Now when I do that, I'm going to put my result underneath my 24. So I put my 15 there, okay? Now what I'm going to do is I'm going to subtract these values, okay? So I'm going to go 24 minus 15, okay? So 24 minus 15 is 9. So I'm going to put my 9 here. Now we go through the whole process again. Okay, so that's kind of one iteration of the process. Now what I'm going to do here is I'm going to check, does 15, so always focusing on your divisor, does 15 go into 9? No, 15 does not go into 9. Okay, so what do I need to do? I need to bring my other 9 down here and write it beside. Now the question is, does 15 go into 99? Well, yes, 15 goes into 99 6 times. So I'm going to put the 6 up at the top here. So since 15 goes into 99 6 times, I put the 6 up at the top there. Now I'm going to take this 6 and I'm going to do the same thing I did with the 1. I'm going to multiply 6. Sorry, one sec. I'm going to multiply 6 by 15. And that gives me 90. Okay, so I put that number here. Now I'm going to subtract again. So again, we're going to do the same thing. We're going to, every time I put a number here, I'm going to subtract, and I get 99 minus 90 is equal to 9. Now at this point, what you may notice at the top is that we have used up my hundreds column. We didn't have to put anything, but it's used. We used up my tens column, and we used up my ones column. Okay, so my hundreds, tens, and ones are all used up. So basically we are out of space at this point. Okay, what you'll also notice is that if I try to see how many times 15 goes into 9, it does not, and I've run out of numbers to bring down from my original dividend. At this point, this tells us that 9 is going to be our remainder. And so what this means is that if I take 249 and I divide that by 15, what I get is I get 16 with a remainder of 9. Okay? Now, what we can say now is we can actually write this in a kind of a formal division statement. And our division statement is written out here for you. Okay, and typically I ask you a question like this, I'm going to be asking you to write out your division statement. And then as we go further in this unit, you're going to see why the division statement is important. Okay, so my division statement is my dividend, which in this case is, oh, I don't know why I wrote a 5, which is 249, is equal to your divisor, which in this case was 15, times my quotient, which was 16, plus my remainder, which was 9. And if you type that into a calculator, 15 times 16 plus 9, you will get 249. Okay, so this process of long division is going to kind of be the foundation of one of the things we're going to do today. I've included long division and synthetic division videos up at the top there for you if you do want to check those out as well. Okay, so dividing a polynomial by another polynomial is similar to long division in arithmetic. Okay, we have some points here. Division of polynomials. 2 methods are used to divide polynomials. And we're going to go over both of them. We have long division and we have synthetic division. Okay, now our rules for long division and synthetic division are the same. There's 2 very important rules. First is you need to ensure that the powers are in descending order. okay? Meaning that your highest exponent of x is at the start, and they go in descending order all the way down, okay? And that has to be true in the divisor and the polynomial, okay? The second key rule is that you need to, and we're going to see some examples of this, insert any missing powers in the polynomial, but using 0 as a coefficient. So basically what these two rules mean is if either my divisor or my dividend look like, and I'll give you an example, we'll say x plus 2x squared minus 3 plus x to the power of 5. Okay, maybe this is my divisor. Okay, notice how it's not, the powers are not in descending order. So that's what I'm going to do first, is I'm going to rewrite this, but I'm going to write my powers in descending order. Now I have an x to the power of 5. I notice here that I do not have a power of x to the power of 4. So that's what we call a missing power. That one's missing. So what I'm going to do is I'm going to put a coefficient of 0. So I'm going to go plus 0 x to the power of 4. Perfect. Now there's no x to the power of 3 in my original equation. So I'm going to go plus 0 x to the power of 3. I'm filling in the missing ones with coefficients of 0. Then I have an x squared, so I'm going to write plus 2x squared. I have an x, so I'm going to write plus x. And I have a minus 3. So this is written out in descending order with any missing powers written in with coefficients of 0. So that's really important, 2 rules. If you ignore those 2 rules, you will not get these questions correct, okay? So what we're going to do, I'm going to show you step-by-step process here of completing long division of the following polynomials. So what we're doing is we are doing 3x cubed plus 2x squared minus 12 minus 11x, and we are dividing that by x plus 1. So the very first thing is the setup. So we are going x plus 1. This is my divisor. And we are going to write that like this. And under here is my dividend, which is 3x cubed plus 2x squared minus 11x. I'm changing the order. Minus 12. Now every power is there. 3, 2, 1, 0. And they are in descending order, the powers. Okay. What I'm going to do now is I'm going to check some things out here. I'm going to see how many times do certain things go into each other. Okay. So we're going to we're always focusing on my x. And every time we do this, we're going to say how many times, or how many times does x go into, and we're first going to look at 3x cubed, okay? Or what would I have to multiply x by to get 3x cubed, okay? Maybe some of you are looking at this and recognize that what I need to multiply by is I need to multiply by 3x squared, okay? Now, there's a couple different ways that we can determine this. Okay. The first thing we can do is, in this case, I can do 3x cubed divided by x. Now that just gives me 3x squared, which is what I put up there. Okay. The second way to do this is trial and error. You can just do guesses, or you can just kind of recognize that by looking. So this is what I get when I divide my 3x cubed by x. You're kind of like you're factoring it out almost. Okay, does that make sense? We're kind of pulling that as a factor out of there. Okay. Now, one thing I want you to notice here is that, and I'm going to put, this does get messy, but I'm going to put some dotted lines down here just to represent that I have an x squared column, I have an x cubed column, I have a x to the power of 1 column, and I have a constant column. So every time I go through another step, every time I write an x squared or x cubed or x down, I'm putting it in the proper column, okay? Now our second step, we figured out what that kind of that first almost factor is. We're going to take that first factor like we did in our earlier example, and we're going to do 3x squared, and we're going to multiply it by my original divisor. Okay? And when I do that, my result is going to be 3x cubed plus 3x squared. Now, in my original example, our step at this point was to subtract these values. So I'm going to subtract, and I'm going to put a nice big bracket around that. Now, when I subtract, okay, I'm doing 3x cubed minus 3x cubed. That gives me 0. Perfect. This should always be the case. That first term should always cancel out. Next, I have 2x squared minus 3x squared, which is just negative 1x squared. Now, we're again going to look at, take this term here, and we're going to say, what would I have to multiply x by to get negative x squared? So we look back to my original divisor, the highlighted yellow here, and what do I need to multiply x by to get negative 1x squared? Well, let's figure it out. Negative 1x squared divided by x. That's just equal to negative 1x. Okay, so this is going to be the next thing I write at the top. Negative 1x. Notice it goes in the x column. Notice also that we're running out of columns. Every time you put a number at the top, your next step is always to multiply it. Negative 1x, and we multiply it by my original divisor, x plus 1. When I do that, I get, what do I get? I get negative 1x squared, and I get negative 1x. Fantastic. Let's do our subtraction. I'm going to subtract here. So negative 1x squared minus negative 1x squared gives me 0. Perfect. And then notice how I have nothing to subtract in my next spot. What I'm going to do is I'm just going to bring this negative 11x down. And now I'm going to subtract. So I'm just going to fill in that column. And negative 11x minus negative 1x is negative 10x. Okay. Now again, we do our next step again. How many times does x, our original x, go into negative 10x? So again, we're going to go negative 10x divided by x. So notice every time I'm dividing by x, what we get is negative 10. That negative 10, I take that, I put it at the top. As soon as I put something at the top, I multiply it by my original divisor. The value that I get, I put in my kind of columns. Negative 10 times x is negative, I put in the wrong column, is negative 10x, and negative 10 times 1 is negative 10. And we're going to do our subtraction again. Subtract. When I do this, negative 10x minus negative 10x is 0. Good. And I'm going to bring this negative 12 all the way down. Negative 12 minus negative 10 is is negative 2. And so this value here is going to be my remainder. Now, why is that? 2 reasons. We have run out of space. We have run out of terms up here. We are literally at the last column. The last column becomes your remainder. Okay, if you have any value down there other than 0, you have a remainder. Okay, so once you reach that last column, you are done. All right. Now what I'm going to do is I'm going to write out my division statement. Okay, so this is it. My division statement is my dividend, so which is 3x cubed plus 2x squared minus 11x minus 12. That's equal to, let's see if I have enough space here, my divisor, which was x plus 1, times my quotient, which is 3x squared minus 1x minus 10, plus my remainder. Since it's negative 2 remainder, we're going to go minus 2. Okay. Now, the idea here is that if I were to FOIL or distribute these brackets, like if I were to expand and simplify this, I would get this. Okay, you can try that. I'm not going to demonstrate that right now, but that would be the case. Okay. Oh, and you see, actually, sorry, I have my division statement down here. I forgot about that. But that's my division statement here. Okay, so this is my dividend. This is my divisor. This is my quotient. And this is my remainder. All right. So the process ends when and this is interesting too here. The process ends when the degree of the remainder is less than the degree of the divisor. Okay. So notice here, and I can point this out to you as well, that what is the degree of the divisor? The degree of the divisor is 1 right here. Okay. And the degree of the remainder, well, the degree of the remainder is just, it's a constant term. There's no x there. So the degree of the remainder is 0. So that also tells us that we're done. Okay. You don't really need to know quotient form here. Okay. We won't really be covering quotient form in this course. So I'm not going to, if you have a question about it, I can talk about that when I'm back. But we're going to skip that kind of for now. Okay. I'm going to do 2 more examples. And I'm going to go through a little bit quicker here. Okay. These 2 here say, and this little note says, if the remainder of the remainder, I think it's just, I think this should just say, sorry, that's a typo. It should say, if the remainder of the polynomial division is 0, both the divisor and quotient are factors. So basically all that says, and you can think of this in terms of numbers, if I do 24 divided by 2, I get 12. I don't get any remainder. That tells me that 2 and 12 are factors of 24. Okay, so that's the same thing here. If I get no remainder, it tells me that the 2 things are factors of the bigger thing. Okay, so let's try this again. Let's do 2 more examples here. Okay, first here we're going to go x minus 2, and we are going x cubed minus, now notice 0x squared, there's no x squared term, minus 2x minus 4. Okay. So this is, I'm always checking how many times x goes into everything. So I'm first going to check out how many times x goes into x cubed. So I'm going to go x cubed divided by x, and I get x squared. Now I might as well put my columns in again here. Okay. And so I get x squared. So I'm going to put that up here. Now, every time I put something up there, I multiply it by my divisor. X squared, I multiply this in, I get x cubed and minus 2x squared. Now remember here, I'm subtracting. I always like to put brackets. X cubed minus x cubed gives me 0, good. And 0 minus negative 2 gives me positive 2x squared. So now I'm going to check how many times x goes into 2x squared. So I'm going to write, okay, 2x squared divided by x. So I'm taking these blue ones and I'm dividing by the yellow one. This gives me 2x. Circle that in green, put that up at the top. 2x. Perfect. I put the number at the top. I'm going to go 2x times my divisor, which is x minus 2. That gives me 2x squared minus 4x. Okay, whoops. I'm going to do my subtraction. 2x squared minus 2x squared is 0. That works every time. I have nothing to subtract, so I'm going to bring down this 2x. It's a negative 2x. And 2x minus negative 4x is positive 2x. So now I'm going to check how many times x goes into this. So I'm going to do 2x divided by x, and I get x. Oh, whoops. That's blue. That's yellow. I take this x, I put it up at the top. Oh, wait. I am mistaken. I get 2. Whoa. I get 2. I put it up at the top. Now I take that 2 and I multiply it by my divisor. That gives me 2x and negative 4. I'm going to do my subtraction. 2x minus 2x is 0. I have nothing to subtract my negative 4 by, so I'm going to bring this negative 4 down. And negative 4 minus negative 4 is 0 remainder. We are done. So what this means is that x cubed minus 2x minus 4 is equal to x minus 2 times x squared plus 2x plus 2. If you multiply that out, you will get, what am I trying to say here? You will get x cubed minus 2x minus 4, okay? Now, because we got no remainder, these are factors of x cubed minus 2x minus 4. So what we've just done is we have partially factored that polynomial, okay? So this is a tool that we're going to use to try to factor polynomials, because we talked about yesterday, we talked about the importance of factoring, how factoring tells us solutions, it's how we find x-intercepts, it's how we solve polynomial equations. And so this is our goal. So I'm giving you tools that are going to help you solve polynomial equations. All right, we're going to do one more example here, and then we're going to kind of move along. So with our next one here, we're going to go, oh, I apologize. I hate when that happens. Let's get my color. So we're going to go 2x plus 3. I'm going to draw this out. We're going to go, oh my gosh. We have 4x cubed plus 6x squared. My gosh. Minus 6x minus 9. Okay. So what am I going to do? I'm going to see how many times 2x goes into 4x cubed. So I'm going to do 2x divide, or sorry. 4x cubed divided by 2x. When I do that, what I get is and I'm going to line this up a little different here. I get 2x squared. I'm going to write that in my x squared column. And then I'm going to multiply that by 2x plus 3. When I do that, I get 4x cubed plus 6x squared. Now I am going to subtract these. I didn't do my columns, but you can do your columns if you want. I do find this to help keep my questions organized. Okay, when I do my subtraction here, what I get is I get 0 and 0. Oh, That's interesting. Okay, so what that means now is I don't have anything to check. So I'm going to bring this negative 6x down. Now I'm going to check how many times does 2x go into negative 6x. So I'm going to go negative 6x divided by 2x. And that's equal to negative 3. Well, I'm going to just change my color. Negative 3. I put that negative 3 up here. Okay. As soon as I write it up there, I now take that negative 3 and I multiply it by 2x plus 3. Negative 3 times 2x is negative 6x. And negative 3 times 3 is negative 9. We're going to do my subtraction. We get 0 here. Put brackets. We get 0 there. Bring my negative 9 down. Negative 9 minus negative 9 is 0 again. And we have run out of space. We have nothing else to bring down. And so 0 is my remainder. And so what we write here is we write our division statement. We say that 4x cubed plus 6x squared minus 6x minus 9 is equal to 2x plus 3 times 2x squared minus 3. Okay? So that is how we use synthetic division. Now, since this is a video, you can always roll through these examples again. I have included some videos at the top of the OneNote page there for you to check out if you want more info on long division. You need to practice this stuff, okay? So you will be assessed on can you use long division to factor polynomials, and so it's important that you do practice this, okay? Now we're going to look at the shorter and better version. It's called synthetic division. The only problem with this one is that it does have some restrictions, okay? And you'll see this as we read through this, but it can't always be used. So there are cases where synthetic division cannot be used and you would be forced to use long division. So this says here, when dividing a binomial of the form, so x minus p or qx minus p, so all this means is like maybe your divisor, is x minus 2 or 2x minus 3. Okay, those would be examples. Division is simplified by using a process called synthetic division. Basically, some mathematician, some brilliant guy, girl, I don't know, some brilliant person, derived this synthetic division from long division, okay? And they basically, what we're doing is we're focusing only on the coefficients. So we're only going to be looking at numerical coefficients here, okay? It can be used only, and this is super important, when the divisor is linear. So if I'm dividing by, if my divisor is a quadratic, if it's a cubic, if it's a quartic, we cannot use synthetic division, okay? So let's look at some examples. All right. So in this first one, okay, what we have is we have x plus 1. So we're dividing by x plus 1. The very first thing we need to do here is we need to determine, and I'm going to do this over on the side here, determine p. Okay, so it says x plus 1 is in the form x minus p. So basically what that means is that, like, if I write x plus 1, this is the same as x minus negative 1, which means that p is equal to negative 1. Think x-intercept, okay? It's kind of like, what would the x-intercept of that factor be? It would be negative 1, because subbing 1 into that gives me 0. Okay? So this is our first one. So what we're going to do here is we are going to use that as our p-value. Now, how this is set up, okay? And once you get this process set up, it's pretty straightforward. But so the setup of this is we take our p-value. I'm going to highlight that in yellow so you see where exactly it's going. We take our p-value, which is -1, and beside it, we're going to draw like a little half box here. Two sides of a box. Okay? Now, the other numbers that we're going to write down is our coefficients. So we're going to write down our coefficients, which is 3x, 3, +2, -12, and -11. Now, what is important here? What rule did we kind of say we needed to remember? The rule that we need to remember is that these are in order. So this has to be 3x cubed plus 2x squared minus 11x minus 12. These need to be in order. So I'm using these values, but I'm making sure that they are in order, okay? And I'm going to write them. I'm going to write them right here. 3, 2, -11, and -12, okay? Excuse me. Now, again, the more you practice this stuff, the better you're going to be. The first time you may be wondering what is going on here. What I also like to do is I also like to sometimes extend these, especially if it's my first time teaching this. I like to put a little plus here and a little multiplication here, okay? Your first step is you always bring this first value straight down and you put it down here, okay? It's your first step every single time. As soon as you put that number down there, as soon as you write any number down there, you take your -1 or your p-value and you multiply it. We're always multiplying. So I go -1 times 3, and I put my answer here, which would be -3. Okay? Now, once I put a number there, this is where the addition comes in. Okay? So I go 2 plus -3, which is -1. As soon as I put a number down here, I am going to multiply it by my p-value. -1 times -1 is +1. Okay? Once I put a number there, and I'm working down, I always do those two numbers I add. So -11 plus 1 is going to give me, excuse me, -10. As soon as I write a number down here, I multiply it by my -1, and I get 10, and I add these two to get -2. Okay, that process is over. Now, what I need to do in this last step is, okay, I'm going to kind of take away these pieces here. Okay? My last step now is I'm going to write out the factors. So I have x plus 1 was my original divisor. Okay? Now my next bracket, so this was my divisor. Okay, my next bracket is going to be my quotient. So my quotient is going to be the 3, the -1, and the -10. Now, what's important here is these were coefficients, and these were coefficients of x to the power of 3, x to the power of 2, x to the power of 1, and x to the power of 0. In my quotient, all that happens is these drop down by 1 degree each. So my x cubed column becomes x squared. My x2 column becomes x1. My -10 column becomes my constant, And my last column here, this -2, is my remainder. And what we've done is we've basically written our division statement. 3x cubed plus 2x squared minus 11x minus 12 is equal to that. That is my division statement. Okay. I'm just going to draw this in again here, these arrows, to show this multiplication. You're multiplying. You're multiplying. You're multiplying. And we don't do it a last time there. Okay. We're going to try this one again. All right. We're going to do it with this one. And I think we do have a couple more examples, but we'll get through these. So with this one here, again, I'm going to maybe go through this a little bit faster in this step, but just make sure you're following along. Again, you can rewatch this video, and you can watch the video at the top. So in this one, I'm going to determine my, so in this one, we have a P and a Q. So I'm kind of trying to figure out what my X, almost what your X-intercept here. That's going to be your P value that we're going to use, okay? Or P over Q value, technically, okay? So what I do here is I'm going to say 2x plus 3. What would be the X-intercept here? I solve for when it's equal to 0. I bring that over. I have 2x equals -3. Divide by 2, divide by 2. My P value, or the value that I'm going to use, is this right here, -3 over 2. So we're going to put -3 over 2. We're going to build kind of my synthetic division box. Okay, I like to put a little plus there, little multiply here. And then we write these out in order with zeros if I have any things missing. So this is going to be, and you can put this at the top too. This is like my x cubed column. This is like my x squared column. This is like my x column. And this is like my constant column. So I have 4, 6, -6, and -9. Okay. Now, if you notice here, this question here is actually the same one that we just did. Okay, we've already done this one. Okay. So we should get the same result. First step, always the same. I'm going to bring this number, I'm going to drop it down. I put a 4 here. Once I do that, I'm going to multiply. Okay. Now, when I multiply here, I get -6. Now, I'm going to add these things. When I add 6 plus -6, I get 0. I'm going to then multiply. When I multiply -3 over 2 times 0, I get 0. Then I add -6 plus 0, I get -6. Then I multiply. When I multiply -3 over 2 by -6, I get +9. And I add. When I add those together, I get 0. We're done. We've run out of space. So how we do this now, we're going to write this out. And we erase these lines. This last number is my remainder. What we're going to do is we're going to write my factor, or my divisor, was 2x -3. Okay? Now, there's one key step here that I'm going to mention before we finish this example. When your p-value has a number that you're dividing by, so in this case the 2 that I've highlighted there, you have to divide, and this is a really unfortunate step because sometimes students forget it, but you have to divide each of your coefficients, your new coefficients, by 2, by that number, okay? And that's going to give me my new coefficients. And so what that gives me is 4 divided by 2 is 2. This was in the x cubed column, right? X cubed was up here. It's going to become x squared. My negative 6 divided by 2 is negative 3. It's in the x column. It becomes a constant. And there is 0 remainder. So writing my division statement out, I don't know if I have enough space over here. I have that. Let's see if I'll write it down at the bottom. 6x squared minus 6x plus 4x cubed minus 9 is equal to 2x minus 3, 2 times 2x squared minus 3. Okay, that one is done. All right, so that is an example there of how to do synthetic division. I'm going to do these last 3 here. It's been 45 minutes, so if I do, I should be able to do these last. I'll do one more of each. I'm going to focus on A and C, and then I'll do this example. So hopefully that'll leave you with about maybe half an hour to try some questions. Okay. That's not going to be enough time. I'm going to do these ones quick. Okay. So this one here, I'm going to go 2x4 minus x3 plus 0x squared plus x plus 3. Okay, I got those written out. My p-value is going to be equal to 1. So I use 1 here. Boom. Okay. Draw my little box. Boom. Use my coefficients. 2, -1, 0, 1, and 3. Okay. I'm going to try to do this one a little quick so you can see that with practice, this can become very quick. Okay. And you do have to do this process a decent amount of times in this unit. My first step, so actually let me do my little boom, boom. This is always plus. When I swing it around, it's always times. Bring my 2 down. Put it here. Then I do 1 times 2, which is 2. Then I add these. -1 plus 2 is 1. Then I multiply. 1 times 1 is 1. Then I add. 0 plus 1 is 1. Then I multiply. 1 plus 1 is 1. Then I add. 1 plus 1 is 2. Then I multiply. 1 times 2 is 2. Then I add. I get 5. I think I made a mistake. Did I make a mistake? Yes. Yes, I made a mistake. Okay, I apologize. Point out my mistake here. My mistake is that this x term should have a 0 coefficient. Okay, which means this term here should actually have a 0 coefficient, which means that this is wrong, this is wrong, and this is wrong. Finishing this up, 0 plus 1 is 1, 1 times 1 is 1, and 3 plus 1 is 4. Okay, my division statement looks like this. 2x to the power of 4 minus x cubed plus 3 is equal to, what was my divisor? It was x minus 1. And now I drop the power of each of these. So this was x4, x3, x2, x1. So my new answer is 2x3. Whoa, that was a really bad 3. 2x to the power of 3 plus 1x squared plus 1x plus 1 with a remainder of 4. Okay? I'm going to skip this one here. With this one, I would just recommend you can try it. You can go 4x cubed plus 0x squared minus 13x minus 6. Actually, you know what? Might as well do it. And we're dividing this by 2x plus 1. Okay? If I go through this one, this is going to be -1 over 2 is going to be my p-value. I'm going to set this up like this. I'm going to go 4, 0, -13, -6. I'm going to drop my 4 down. -1/2 times 4 is -2. 0 plus -2 is -2. Negative a half times negative 2 is 1. Negative 13 plus 1 is negative 12. And negative a half times negative 12 is positive 6. Negative 6 plus 6 is 0. Okay, I need to remember that because I'm dividing by 2 here, or I have a divisor of 2, I'm going to divide each of these terms by 2. And what I get is 2x plus 1 times, drop my exponents down 1, so this becomes 2x squared minus x minus 6 is equal to, and that was, I think, 4x cubed minus 13x minus 6. Okay? One more here that we'll do, and this is a bit of a big one, is it says here that, what am I saying here? Okay, this one, because this is not linear, we have to use long division. So one more practice of long division here. We're going to go x squared minus 1. We have x5 plus 0, x4 minus x3 minus x2 plus 0x plus 1. Okay. X squared goes into x5 3 times. Or sorry, x to the 3. So I put x to the 3 up here. And then I'm going to go x to the 3 times x squared minus 1. When I do that, I get x to the 5 minus x to the 3. When I subtract, x to the 5 minus x to the 5 is 0. Negative x to the 3 minus, I bring this one down. I get plus 0. That's just 0. Negative x to the 3 minus negative x to the 3 is plus 0. Those all cancel each other out. I don't have anything to check. I'm going to bring this one down. I get negative x squared. So how many times does x squared go into negative x squared? Well, it goes in, and you could do that over here, negative x squared divided by x squared. It goes in negative 1 times. I put negative 1 in the constant column. And then I times negative 1 by my divisor. What I get is I get negative x squared, which is perfect, and I get plus 1. I do my subtraction. Negative x squared minus negative x squared is 0. This 0 just comes all the way down, plus 0. 1 minus, so bring this 1 down. 1 minus 1 is 0. Remainder. So, what is my factor? What is my division statement? It's x to the 5 minus x cubed minus x squared plus 1 is equal to, I divided by x squared minus 1, and I got a result of x cubed minus 1. You could try to FOIL that, and you would get, that would work out pretty well. Okay? Last question. When a certain polynomial is divided by x minus 2, the quotient is 2x squared minus x5 plus 5, and the remainder is 4. It says, what is the polynomial? So here we are given, I'm going to write out your division statement. Your division statement is dividend equals divisor times quotient plus remainder. In this question, you are going, this is your divisor, this is your quotient, and this is your remainder. I'm going to fill those things in. So we're going to go D equals, my divisor is x minus 2. My quotient is 2x squared minus x plus 5. And my remainder is 4. All we're doing here is we're looking for the dividend. So I'm going to FOIL these brackets. I'm going to go boom, 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 boom. Multiply everything in those brackets. When I do that, I get 2. x cubed minus x squared minus 2, not that's right, I got to slow down, plus 5. Then I get negative 4x squared plus 2x minus 10, and my plus 4 stays at the end. Now collecting my like terms, I get 2x cubed minus 5x squared plus 2x, 5 minus 10, negative 5 plus 4 is negative 1. And so that is what my dividend is, or that is what the polynomial is. Okay. I will be back in class on Monday. If you have any questions, you can always shoot me an email. I'll try to get back to you at some point, either today or over the weekend. Otherwise, I will see you next week. Have a great weekend.